Okay. In the previous class, we were discussing the combinations of regeneration, reheating, and intercooling, isn't it? If a reheating is being introduced into a Breton cycle, how actually the component flow would be there, how actually the TS diagram would be there, we were discussing in the last class, isn't it? And there is a small change in the concepts what I have explained here. I was just referring few of the textbooks after I finished my class because that class was not planned yet. It was just went in a flow as I've told you in the class end. So there is a small concept change. Okay. Everything is, this is a normal Breton cycle. No change here. Regenerative in the sense, what I have done is, previously I have clubbed these two, isn't it? Clubbed these two and shown this as a regeneration. No. So regeneration happens here. So the output of the turbine is been sent back to heat the incoming gas to the combustion chamber. The incoming gas to the combustion chamber. So this is the only change that is there. Everything else was correct in what I have delivered. Is that clear? Understood? Yes or no? That is why Anish was asking me, sir, 5 should come in between 2 and 3. But it was, previously it was from 1 to 4. Right, Anish?
Yes, sir.
So now it's been clear, I guess, right?
Yes, sir.
Okay. So this is the only change which has to be changed. Okay. Like, see. So this is a Breton cycle with intercooler. Intercooler, when does the intercooler is introduced, what happens? When an intercooler is introduced, what happens actually? Whether you are changing, compressing in 2 stages,
Temperature.
or whether you are expanding in 2 stages when an intercooler is introduced. Whether you are compressing in 2 stages or whether you are expanding in 2 stages when an intercooler is introduced. That is my question. Yes, when an intercooler is introduced, compression process takes place in 2 different stages. When a reheater is being introduced, the expansion process would takes place in 2 different turbines. Clear with this? So when an intercooler is there, what happens? Your compression process would occur in 2 different stages, a low pressure compressor and a high pressure compressor. After the first compression, you will intercool it. That means you'll cool down to the initial or the lowest value. Then again you compress it. So that is what intercooler is there. When an intercooler is being introduced, you are compressing in 2 different stages. Whereas when reheater is being introduced, what are you doing? You are expanding it to a certain level. Again, you are heating it back. Again, you are heating it back. Again, you are expanding. Okay, that is what is happening there. So this is reheater. So what happens when all the three are there? This is the combination of intercooler and reheater. So intercooler in the sense 2 stages compression, reheater in the sense 2 stages expansion. So a Breton cycle with reheater as well as intercooler is 2 stages of compression, and also you have 2 stages of expansion. Now what if I introduced regenerator, reheater and intercooler? Okay, so there would be no doubt there would be 2 stages of compression because there is a presence of intercooler. Now, again, there will be 2 stages of expansion because there is a presence of the reheater. And there would be a regeneration point, which is 0.9, according to the numbering. Just I have given the numbering. So, according to this, there will be a point because there is a regenerator. And the heat addition would only be accounted from 9 to 5. Okay, because this particular amount of heat, 4 dash to 9 is there no amount of heat. It is obtained by regeneration. So that much amount of heat you are saving there. That is what it means literally. Any doubts about this concepts which we have discussed in the last class? If there are no doubts, we will move to that particular problem. Okay. Yes. Any doubts?
No, sir.
Okay. So come to this particular problem now. Where it is? Oh, I will just shift this. Okay. Right. So this is the problem. I just picked it from the textbook. Okay. Now, air is drawn. Shall we start?
Yes, sir.
No. Now, after learning all those concepts, now you have to say me how this particular problem is done. The air is drawn in a gas turbine at 15 degrees Celsius and 1.01 bar. So what is this? Values 15 degrees Celsius and 1.01 bar.
P1 and
Temperatures and
P1.
pressures.
Very good. So it is P1, which is 1.01 bar, and you have the value of T1, which is 15 degrees Celsius. Can anyone give me the value in Kelvin? 15 degrees Celsius Kelvin value.
288.
288 Kelvin. Now next, the pressure ratio is 7:1. So what is pressure ratio?
P2.
P2 by P1, that is equal to P3 divided by P4, that is equal to beta, that is 7 for this particular problem. Next, the compressor is driven by HP turbine and LP turbine, drives a separate power shaft. Okay, so the first point what he has given, so carefully observe, the compressor is driven by HP turbine, he says. The compressor is driven by HP turbine. Okay, LP turbine drives a separate power shaft. That means he is talking about the HP turbine and LP turbine. So how many turbines are there here?
2.
How many?
2.
There are two turbines, isn't it? So if there are two turbines, that means this is a Brayton cycle with regenerator, or it is a Brayton cycle with intercooler, or this is a Brayton cycle with reheater. Which one is this?
Reheater.
Very good. So just to draw a Brayton cycle with a reheater. So how does it look? So there would be a compressor. So there would be a single compressor, isn't it? Only on the compressor. So this is stage 1. From here, there would be a combustion chamber, right? CC. From here, there would be a turbine. So how many turbines? How many turbines?
2.
Two turbines. So this is a compressor. First thing is a HP turbine. HPT I would just write there. Correct? HP turbine, and output of this is connected to what?
LP.
Reheater. Reheater.
Very good. So this is connected to a reheater. I would just write here. Okay, output of this is connected to reheater. From reheater, again, you are expanding the things like this in a LP turbine. Okay, and you are leaving it out. LP turbine. Now, just name the state points. Compression happens from state 1 to state 2. From state 2 to state 3, heat addition happens. From 3 to 4, first stage of expansion happens in the HP turbine. From 4 to 5, you are reheating it once again. So from 5 to 6, you are expanding it again in an LP turbine. So how many of you would draw the TS diagram for this particular uh, arrangement? Okay. So how many stages of compression here? How many stages of compression? How many stages of compression?
One.
One, isn't it? So there is only one stage of compression like this. Okay, so from 1 to 2 isentropically, that means adiabatically it would compress. From 2 to 3, what happens? The heat addition process takes place like this. So this is the heat addition process which takes place isobarically, constant pressure there. So that is why it is a curve in a TS diagram. Next, expansion happens in two different stages, isn't it? First, from 3 to 4, little bit of expansion happens like this. Same diagram, it's already been taught in the last class. 3 to 4, small expansion happens. From, again, what you can say, from 4 to 5, a heat addition, that is reheating process happens like this. So the reheating, little bit of heat is again increased. Yes. So from 5 to 6, one more turbine is there, which is LP turbine. Isentropically, again, it gets expanded like this, and it comes back isobarically with this particular line here to the state 1. So this is the overall representation of your TS diagram. Okay. Understood? So if you have observed carefully, there are three isobaric processes, right? Isobaric process I'm talking about. So first isobaric process is this, right? So this happens at a one particular pressure, right?
Yes, sir.
Yes or no?
Yes, sir.
And second one is this isobaric process. So isobaric in the sense it will be a curve in a TS diagram. And third isobaric process is the heat rejection process. All heat related process would be an isobaric process. Keep this in mind. All heat related process would be an isobaric process. So what I would do is, for my understanding of these better, I would draw an isobars like this. So this is an first isobar, second and third. So three isobaric process would take place like this, isn't it? Correct. And this particular, what can I say? This one, 2 to 3, which is the heat addition process, takes place at which pressure? Anyone? Okay, he has not given. Don't worry about it. So 6, isn't it? This is 6 now. Which value of pressure is being given? Which value of pressure is given in this particular problem?
First page. First.
Okay, only P1, the pressure at state 1. So which is how much? I would just write here. It is 1.01 bar. Okay, so all this heat rejection process would takes place at which pressure? It would takes place at 1.01 bar. Now, can I get the value of P2? Is there any way through which I can calculate the value of P2?
P1 by P2 is equal to 7. P2 value is given. P1 value is given.
Exactly. So beta, since beta value is given as 7 and beta value is P2 by P1, that is equals to 7. So I want the value of P2. It is P1 times the 7. So P1 is 1.01 cross 7. So what is the value of P2?
7.07.
So 7.07. Now you see all this heat addition process from 2 to 3 takes place at a pressure of how much? Takes place at a pressure of how much?
1.01.
Oi, heat addition kana idu Aditya.
7.07.
It's 7.07 bar pressure ಅಲ್ಲಿ ಈ ಎಲ್ಲ process heat addition process ಆಗ್ತದೆ. ಕೆಳಗಡೆದು 1.01. Now, so similarly, I have to find at what pressure this particular process, which is 4 to 5, which is happening. That means what is the pressure at which this particular isobar is passing. Even that I have to find, we will go through it. Understood the problem, everyone, until now? Any
Yes, sir.
doubts? Clear ಆಯ್ತಾ? ಹೇಗೆ ನಾವು ಕಾನ್ಸೆಪ್ಟ್ ನ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕು ಅಂತ ಪ್ರಾಬ್ಲಮ್ ಇಂದ? Still the problem is pending. We will just complete it. Okay, now there is one more thing, guys. He says clearly here, the compressor is driven by HP turbine. That means your compressor is there, no? It is driven by HP turbine. That means whatever the work output which is generated by the HP turbine, it's being transferred to what? Is being transferred to the compressor. So can I say that the output of the HP turbine, that means work done in an HP turbine, is equal to the compressor work output? Can I say whatever the work output which is generating using a HP turbine, can I say it is grabbed by compressor? Therefore, the work of HP turbine, can I say it is equal to work of compressor? Yes or no?
Yes.
So here clearly it is being given. The compressor is driven by HP turbine, and LP turbine drives a separate power shaft, he says. Now, where is LP turbine? This is the LP turbine. What it would do is, there is a power. Okay, is that fine? So LP turbine, whatever the power output of LP turbine is there, so that is connected to a what? That is connected to generator. That is connected to a generator. Okay, so whatever the output of the LP turbine is there, so from that particular thing you are generating the power. That is what it means. Okay, next. The isentropic efficiency of the compressor and HP and LP turbines are 0.82, 0.85 and 0.85, he says. That means what he has given us the value of efficiency of the compressor. That is how much? Efficiency of compressor is 0.82. Now, what is the efficiency of HP turbine? It is 0.85.
0.85.
Yes, thank you, dear. HP turbine is 0.85, and even the efficiency of LP turbine is given 0.85. Now, guys, you have to say me what are the necessary changes I should make in my TS diagram so that I would compensate compensate on the efficiency values which is given.
T2 dash, 2 dash, 4 dash, and 6 dash.
Hey,
Pressure.
excellent, Aditya. Excellent. Very good. Superb. Now, so what I have to do? So this would deviate just because efficiency of the compressor is given. So this would deviate to 2 dash. Now from 3 to 4 dash, 3 to 4 it has to be moved. But since the efficiency of HP turbine is given, this would deviate like this and meet at 4 dash like this. And similarly, since the efficiency of the LP turbine is also given, this would deviate here and meet at 6 dash. Excellent, guys. Very good. Four dash, 6 dash. Is the problem. Next. In Kedidane. Okay, if the maximum cycle temperature is 610 degrees Celsius, so which is the maximum cycle temperature? Whether it is T1, T2,
T3.
T3. Very good. So T3 value is being given. Please give me the value in the Kelvin directly. How much is the value?
$883.
883 Kelvin. So T3 value is given, that we have noted it down. Now, what we need to find? Pressure and temperature of the gas entering the power turbine. Power turbine in the sense, it is that particular turbine from which electricity is generated, whether it is HP turbine or whether it is LP turbine, from which power is being generated, whether the power is being generated from the HP turbine or whether the power is being generated from the LP turbine in this case, in this particular problem.
LP.
LP turbine. So LP turbine will give you the power output. So what he has asked in the power turbine, pressure and temperature of the gas entering the power turbine, he says. So which are those two values? Whether it is P3, P4, what is that? Which one is that? What we need to find?
P5.
What we, so it's the pressure and temperature of the gas entering the power turbine.
T5. P5.
P5 and T5 has to be found out. Okay, next, what else? What else? The net power developed by unit per kg per second mass flow, he says. So basically, he wanted to convey that you must calculate the value of the W net. So what is the value of W net, guys? How many work done are there, by the way, in this particular problem? How many work done?
3.
Very good. So here, it is a combination of WC plus WHP turbine plus WLP turbine. So this is the combination of all these three. Okay. Next. What else? That is being asked. So work net you have to calculate. And here clearly he has specified that you have to consider it for the unit mass basis. So I would just write in the bracket, it is with respect to unit mass basis. So if it is respect to unit mass basis, you can neglect the value of M. That's great. Work ratio he has asked us to find. So how will you calculate the work ratio? Already we have discussed this. How many of you remember it? How will you calculate the work ratio?
W net divided by positive work.
Whether it is a reciprocal of your answer? Just check.
No, sir. Divided by positive work. Yeah.
Okay. So W net divided by the positive work. Okay. So now W net, you will have the value here. So no issue. W net divided by what is positive work here? So how many positive works are there? How many positive works are there? How
And
many?
this is two, but we have to take only one, no?
But
The
why?
two are there, but
Hmm.
HP work is transmitted to compressor.
Yes, it is transferred to compressor. We are not cared about which one is being absorbing. So, like, see, for example, you take the example of a compressor, whether it is absorbing the work or whether it is giving the work.
Absorbing.
Oi, whether it is absorbing the work or whether it is giving the work. Someone told giving. Once more, whether the compressor is
Absorbing, no?
absorbing the work or whether it is giving the work.
Absorbing.
So it's absorbing the work. Okay, so that you have to understand. Now, whether HP turbine is giving the work or absorbing the work.
Giving.
Giving.
Giving the work. So that's why this is positive. And whether LP turbine is giving the work or absorbing the work.
Giving.
Giving the work. So that's why it is positive. Irrespective, but it might be WC might be equal to WHP turbine according to Anish. No issue there. But yet you have to consider the whole lot of thing. All three different work done you have to calculate. Out of which two are positive in nature and one is negative in nature. All the three have to take into account. Is that clear?
Yes, sir.
WF turbine, sorry, positive work in the sense WHP turbine plus WF LP turbine. So these two are positive work. Now, what is the fourth point that you need to calculate? What is the fourth point? The thermal efficiency of the unit. So how will you calculate the thermal efficiency of the unit? Efficiency of Breton cycle, anyone? So it is output by input, that is W net, divided by input, heat input, that is the value of QS. So how will you calculate in this? Anyone. So W net you already calculated while calculating here. So here it is WC, WHP turbine, WLP turbine. Already calculated it. Now, how will you calculate QS? That is my curiosity now. W net.
2 to 3 to 4 to 5
Excellent,
QS.
Anesh. It is cube 2 to 3 plus since you are adding up heat in two different segments, that is one in the combustion chamber and other one is in a reheater. So you have to consider these two at a single stretch. For example, 2 dash to 3. Okay, since the efficiency is given, you have to consider the dash there. So from 2 dash to 3, whatever the heat input is there, that you have to consider. And one more thing is from 4 dash to 5. So this is also a heat addition in a reheater. So both the things you have to consider. Okay. So KIF 2 dash to 3 and it is 4 dash to 5. Now, everyone got the clarity about the problem? Yes or no?
Yes.
Understood the problem? Okay, now, so you try this particular problem. Okay, I have a little bit of work to do.